Tiananmen Square in the data?
Yes, but is it going to catch wordplay or encoded
I mean,
language?
people have
That's
been
the same
memeing
thing.
on like games and other stuff how to like say things that don't say Tiananmen Square. Or like, yeah, so there's always like different ways to do it. There's, hey, the internet as a whole does tend to just have a slight left bias, right? Because it's always been richer, more affluent, younger people on the internet relative to the rest of the population. So there is already inherently a slight left bias, right, on the internet. And so how do you filter things that are this complicated, right? Is it like, and some of these can be like, factual, non-factual, but like Tiananmen Square is obviously the example of a factual, but it gets a lot harder when you're talking about aligning to a ideal, right?
Which
and,
is
Yeah.
and so Grok, for example, right? Elon's tried really hard to make the model not be super PC and woke, but the best way to do pre-training is to throw the whole freaking internet at it, right? And then later figure out. But then at the end of the day, the model at its core now still has some of these ideals, right? You still ingested Reddit/r/politics, which is probably the largest political discussion board on the world that's freely available to scrape. And guess what? That's left leaning, right? There are some aspects like that you just can't censor unless you try really, 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 really hard.
So the base model will always have some TDS, Trump derangement syndrome, because it's trained so much.
it'll have the
I
ability
don't know
to
if you,
express it.
but what if you?
There's a wide representation in the data.
So this is what happens. It's like a lot of modern, what is called post training. It's a series of techniques to get the model on rails of a really specific behavior.
And I mean, it's like you also have the ingested data of like Twitter or like Reddit/r/the Donald, which is like also super pro Trump, right? And then you have like fascist subreddits or like you have communist subreddits.
Secure
So
the base sector
the
by
model
sector.
in
Your
pre-training
force is
ingests
limited, and the
everything.
Americans will attempt to
It has
drag
no
out the
worldview.
engagement.
Now it does
Strike
have like
decisively, and this risk
some
to the world
skew
can be put
because
under
more of the
Russian
text
control.
is skewed a certain way, which is general, like slight left, like, but also like somewhat like intellectual, somewhat like it's just like the general internet is a certain way. And then as Nathan's about to describe eloquently, right? Like you can elicit certain things out.
And there's a lot of history here, so we can go through multiple examples and what happened. Llama 2 was a launch that the phrase like too much RLHF or like too much safety was a lot. It's just that was the whole narrative after Llama 2's chat models released. And the examples are sorts of things like you would ask Llama 2 chat, how do you kill a Python process? And it would say, I can't talk about killing because that's a bad thing. And anyone that is trying to design an AI model will probably agree that that's just like, model, you messed up a bit on the training there. I don't think they meant to do this, but this was in the model weight. So this is not like it didn't necessarily be, there's things called system prompts, which are when you're querying a model, it's a piece of text that is shown to the model, but not to the user. So a fun example is your system prompt could be talk like a pirate. So no matter what the user says to the model, it'll respond like a pirate. In practice, what they are is you are a helpful assistant. You should break down problems. If you don't know about something, don't tell them. Your date cutoff is this, today's date is this. It's a lot of really useful context for how can you answer a question well.
And Anthropic publishes their system.
Yeah, which I think is great. And there's a lot of research that goes into this. And one of your previous guests, Amanda Askell, is like probably the most knowledgeable person that, at least in the combination of execution and sharing. She's the person that should talk about system prompts and character of models.
Yeah, and then people should read these system prompts because you're like trying to nudge, sometimes through extreme politeness, the model to be a certain way.
And you could use this for bad things. I mean, we've done tests, which is, what if I tell the model to be a dumb model? Like, which evaluation scores go down? And it's like, we'll have this behavior where it could sometimes like say, oh, I'm supposed to be dumb. And sometimes it's like, it doesn't affect like math abilities as much, but something like if you're trying, it's just the quality of a human judgment would draw to the force. Let's go back to post-training, specifically RLHF around Llama 2 it was too much safety prioritization was baked into the model weights. This makes you refuse things in a really annoying way for users. It's not great. It caused a lot of like awareness to be attached to RLHF that it makes the models dumb.
And it stigmatized the word.
It did in AI culture. And as the techniques have evolved, that's no longer the case, where all of these labs have very fine-grained control over what they get out of the models through techniques like RLHF.
Although different labs are definitely different levels. Like on one end of the spectrum is Google, and then like maybe OpenAI does less and Anthropic does less. And then like on the other end of the spectrum is like XAI, but they all have different forms of RLHF trying to make them a certain way.
And the important thing to say is that no matter how you want the model to behave, these RLHF and preference tuning techniques also improve performance. So on things like math evals and code evals, there is something innate to these, what is called contrastive loss functions. We could start to get into RL here, we don't really need to, but RLHF also boosts performance on anything from a chat task to a math problem to a code problem. So it is becoming a much more useful tool to these labs. So this kind of takes us through the arc of, we've talked about pre-training, hard to get rid of things. We're talking about post-training and how post-training, you can mess it up. It's a complex, multifaceted optimization with 10 to 100 person teams converging on one artifact. It's really easy to not do it perfectly. And then there's the third case, which is where we talked about Gemini. The thing that was about Gemini is this was a served product where Google has their internal model weights that have done all these processes that we talked about. And in the served product, what came out after this was that they had a prompt that they were rewriting user queries to boost diversity or something. And this just made it, the outputs were just blatantly wrong. It was some sort of organizational failure that had this prompt in that position. And I think Google executives probably have learned this. I didn't pay that attention in that detail, but it was just a mess up in execution that led to this ridiculous thing, but at the system level. The model weights might have been fine.
So at the very end of the pipeline, there was a rewriting.
To something like a system prompt. It was like the system prompt, or what is called in industry is like you rewrite prompts. So especially for image models, if you're using DALL-E or ChatGPT can generate you an image, you'll say, draw me a beautiful car. With these leading image models, they benefit from highly descriptive prompts. So what would happen is if you do that on ChatGPT, a language model behind the scenes will rewrite the prompt, say, make this more descriptive, and then that is passed to the image model. So prompt rewriting is something that is used at multiple levels of industry, and it's used effectively for image models, and the Gemini example is just a failed execution.
Big philosophical question here with the RLHF, to generalize, where is human input, human in the loop, human data most useful at the current stage?
For the past few years, the highest cost human data has been in these preferences, which is comparing, I would say, highest cost and highest total usage. So a lot of money has gone to these pairwise comparisons where you have two model outputs and a human is comparing between the two of them. In earlier years, there was a lot of this instruction tuning data, so creating highly specific examples to something like a Reddit question to a domain that you care about. Language models used to struggle on math and code, so you would pay experts in math and code to come up with questions and write detailed answers that were used to train the models. Now it is the case that there are many model options that are way better than humans at writing detailed and eloquent answers for things like model and code. So they talked about this with the Llama 3 release, where they switched to using Llama 3, 4, or 5b to write their answers for math and code, but they, in their paper, talk about how they use extensive human preference data, which is something that they haven't gotten AIs to replace. There are other techniques in industry like constitutional AI where you use human data for preferences and AI for preferences, and I expect the AI part to scale faster than the human part. But among the research that we have access to is that humans are in this kind of preference loop.
So as reasoning becomes bigger and bigger and bigger, as we said, where's the role of humans in that?
It's even less prevalent. So it's the remarkable thing about these reasoning results, and especially the DeepSeek R1 paper, is this result that they call DeepSeek R10, which is they took one of these pre-trained models, they took DeepSeek V3 base, and then they do this reinforcement learning optimization on verifiable questions or verifiable rewards for a lot of questions and a lot of training, and these reasoning behaviors emerge naturally. So these things like, wait, let me see, wait, let me check this, oh, that might be a mistake, and they emerge from only having questions and answers. And when you're using the model, the part that you look at is the completion. So in this case, all of that just emerges from this large-scale RL training, and that model, which the weights are available, has no human preferences added into the post-training. The DeepSeek R1 full model has some of this human preference tuning, this RLHF after the reasoning stage. But the very remarkable thing is that you can get these reasoning behaviors, and it's very unlikely that there's humans writing out reasoning chains. It's very unlikely that they somehow hacked OpenAI and they got access to OpenAI O1's reasoning chains. It's something about the pre-trained language models and this RL training where you reward the model for getting the question right. And therefore it's trying multiple solutions, and it emerges this chain of thought.
This might be a good place to mention the eloquent and the insightful tweet of the great and the powerful Andrej Karpathy. I think he had a bunch of thoughts, but one of them, last thought, not sure if this is obvious. You know something profound is coming when you're saying it's not sure it's obvious. There are two major types of learning, in both children and in deep learning. There's one, imitation learning, watch and repeat, i.e. pre-training, supervised fine-tuning, and two, trial and error learning, reinforcement learning. My favorite simple example is AlphaGo. One is learning by imitating expert players. Two is reinforcement learning to win the game. Almost every single shocking result of deep learning, and the source of all magic, is always two. Two is significantly more powerful. Two is what surprises you. Two is when the paddle learns to hit the ball behind the blocks and break out. Two is when AlphaGo beats even Lee Sedol. And two is the aha moment when the DeepSeek or O1, etc. discovers that it works well to reevaluate your assumptions, backtrack, try something else, etc. It's the solving strategies you see this model use in its chain of thought. It's how it goes back and forth thinking to itself. These thoughts are emergent, 3 exclamation points. And this is actually seriously incredible, impressive, and new, and is publicly available and documented. The model could never learn this with imitation, because the cognition of the model and the cognition of the human labeler is different. The human would never know to correctly annotate these kinds of solving strategies and what they should even look like. They have to be discovered during reinforcement learning as empirically and statistically useful towards the final outcome. Anyway, the AlphaZero sort of metaphor analogy here. Can you speak to that, the magic of the chain of thought that he's referring to?
I think it's good to recap AlphaGo and AlphaZero because it plays nicely with these analogies between imitation learning and learning from scratch. So AlphaGo, the beginning of the process was learning from humans, where they started this is the first expert level Go player or chess player in DeepMind's series of models where they had some human data. And then why it is called AlphaZero is that there was zero human data in the loop. And that change to AlphaZero made a model that was dramatically more powerful for DeepMind. So this remove of the human prior, the human inductive bias, makes the final system far more powerful. This we mentioned Bitter Lesson hours ago, and this is all aligned with this. And then there's been a lot of discussion in language models. This is not new. This goes back to the whole Q-star rumors, which, if you piece together the pieces, is probably the start of OpenAI figuring out its O1 stuff when last year in November the Q-star rumors came out. There's a lot of intellectual drive to know when is something like this going to happen with language models, because we know these models are so powerful and we know it has been so successful in the past. And it is a reasonable analogy that this new type of reinforcement learning training for reasoning models is when the door is open to this. We don't yet have the equivalent of turn 37, which is the famous turn where the DeepMind's AI playing Go stumped Lee Sedol completely. We don't have something that's that level of focal point, but that doesn't mean that the approach to technology is different and the impact of the general training is still incredibly new.
Well, what do you think that point would be? What will be move 37 for chain of thought, for reasoning?
Scientific discovery, like when you use this sort of reasoning problem and it just something we fully don't expect.
I think it's actually probably simpler than that. It's probably something related to computer user robotics rather than science discovery. Because the important aspect here is models take so much data to learn, they're not sample efficient, right? They take the entire web, right? Over 10 trillion tokens to train on, right? This would take a human thousands of years to read, right? A human does not... And humans know most of the stuff, a lot of the stuff models know better than it, right? Humans are way, way, way more sample efficient. That is because of this self-plate, right? How does a baby learn what its body is? As it sticks its foot in its mouth and it says, oh, this is my body, right? It sticks its hand in its mouth and it calibrates its touch on its fingers with the most sensitive touch thing on its tongue, right? Like, it's how babies learn. And it's just self-play over and over and over and over again. And now we have something that is similar to that, right? With these verifiable proofs, right? Whether it's a unit test in code or a mathematical verifiable task, generate many traces of reasoning, right? And keep branching them out, and then check at the end, hey, which one actually has the right answer? Most of them are wrong, great. These are the few that are right. Maybe we use some sort of reward model outside of this to select even the best one to preference as well. But now you've started to get better and better at these benchmarks. And so you've seen over the last 6 months a skyrocketing in a lot of different benchmarks, right?
All math and code benchmarks are pretty much solved, except for frontier math, which is designed to be almost questions that aren't practical to most people because they're exam level open math problem type things. So it's like on the math problems that are somewhat reasonable, which is like somewhat complicated word problems or coding problems. This is just what Dylan is saying.
So the thing here is that these are only with verifiable tasks. We earlier showed an example of the really interesting, like what happens when chain of thought is to a non-verifiable thing. It's just like a human, chatting, right, with thinking about what's novel for humans, right, a unique thought. But this task and form of training only works when it's verifiable. And from here, the thought is, okay, we can continue to scale this current training method by increasing the number of verifiable tasks. In math and coding probably has a lot more to go. Math has a lot less to go in terms of what are verifiable things. Can I create a solver that then I generate trajectories toward or reasoning traces towards, and then prune the ones that don't work and keep the ones that do work? Well, those are going to be solved pretty quickly, but even if you've solved math, you have not actually created intelligence, right? And so this is where I think the aha moment of computer use or robotics will come in, because now you have a sandbox or a playground that is infinitely verifiable, right? Did you, messing around on the internet, there are so many actions that you can do that are verifiable. It'll start off with log into a website, create an account, click a button here, blah, blah, blah. But it'll then get to the point where it's, hey, go do a task on Tasker or whatever all these various task websites. Hey, go get hundreds of likes, right? And it's going to fail. It's going to spawn hundreds of accounts. It's going to fail on most of them. But this one got to 1,000. Great. Now you've reached the verifiable thing. And you just keep iterating this loop over and over. And that's when, and same with robotics, right? That's where, where you have an infinite playground of tasks like, hey, did I put the ball in the bucket? All the way to oh, did I build a car, right? There's a whole trajectory to speedrun or, what models can do. But at some point, I truly think that we'll spawn models, and initially all the training will be in sandboxes. But then at some point, the language model pre-training is going to be dwarfed by what is this reinforcement learning. You'll pre-train a multimodal model that can see, that can read, that can write, blah, 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 whatever, vision, audio, etc. But then you'll have it play in a sandbox infinitely and figure out math, figure out code, figure out navigating the web, figure out operating a robot arm, right? And then it'll learn so much, and the aha moment I think will be when this is available to then create something that's not good, right? Oh, cool, part of it was figuring out how to use the web. Now all of a sudden it's figured out really well how to just get hundreds of thousands of followers that are real and real engagement on Twitter, because all of a sudden this is one of the things that are verifiable.
And maybe not just engagement, but make money.
Yes,
that could be the thing where almost fully automated, it makes $10 million by being an influencer, selling a product, creating the product, I'm not referring to a hype product, but an actual product. Holy shit, this thing created a business. It's running it. It's the face of the business, that kind of thing. Maybe a number one song, it creates the whole infrastructure required to create the song, to be the influencer that represents that song, that kind of thing. It makes a lot of. That could be the move. Our culture respects money in that kind of way,
and it's verifiable, right?
It's verifiable, right?
The bank account can't lie.
Exactly.
There's surprising evidence that once you set up the ways of collecting the verifiable domain, that this can work. There's been a lot of research before this R1 on math problems, and they approach math with language models just by increasing the number of samples. So you can just try again and again and again, and you look at the amount of times that the language models get it right, and what we see is that even very bad models get it right sometimes. And the whole idea behind reinforcement learning is that you can learn from very sparse rewards. So it doesn't, the space of language and the space of tokens, whether you're generating language or tasks or a robot, is so big that you might say that it's like, I mean, the tokenizer for a language model can be like 200,000 things. So at each step, it can sample from that big of a space. So if it can generate a bit of a signal that it can climb onto, that's what the whole field of RL is around, is learning from sparse rewards. And the same thing has played out in math, where it's like very weak models that sometimes generate answers. We see research already that you can boost their math scores. You can do this sort of RL training for math. It might not be as effective, but if you take a 1 billion parameter model, so something 600 times smaller than DeepSeek, you can boost its grade school math scores very directly with a small amount of this training. So it's not to say that this is coming soon. Setting up the verification domains is extremely hard, and there's a lot of nuance in this, but there are some basic things that we have seen before where it's at least expectable that there's a domain and there's a chance that this works.
All right, so we have fun things happening in real time. This is a good opportunity to talk about other reasoning models, O1, O3. Just now, OpenAI, as perhaps expected, released O3 Mini. What are we expecting from the different flavors? Can you just lay out the different flavors of the O models and from Gemini, the reasoning model?
Something I would say about these reasoning models is we talked a lot about reasoning training on math and code. And what is done is that you have the base model we've talked about a lot on the internet. You do this large scale reasoning training with reinforcement learning. And then what the DeepSeek paper detailed in this R1 paper, which for me is one of the big open questions on how do you do this, is that they did reasoning heavy but very standard post-training techniques after the large-scale reasoning RL. So they did the same things with a form of instruction tuning through rejection sampling, which is essentially heavily filtered instruction tuning with some reward models, and then they did this RLHF, but they made it math heavy. So some of this transfer, we looked at this philosophical example early on. One of the big open questions is how much does this transfer? If we bring in domains after the reasoning training, are all the models going to become eloquent writers by reasoning? Is this philosophy stuff going to be open? We don't know in the research of how much this will transfer. There's other things about how we can make soft verifiers and things like this, but there is more training after reasoning, which makes it easier to use these reasoning models, and that's what we're using right now. So if we're going to talk about O3 Mini and O1, these have gone through these extra techniques that are designed for human preferences after being trained to elicit reasoning.
I think one of the things that people are ignoring is Google's Gemini Flash Thinking is both cheaper than R1 and better. And they released it in the beginning of December.
And nobody's talking about it.
No one cares.
It has a different flavor to it. Its behavior is less expressive than something like O1, or it has fewer tracks that it is on. Qwen released a model last fall, QWQ, which was their preview reasoning model. And DeepSeek had R1 Lite last fall, where these models kind of felt like they're on rails, where they really, really only can do math and code. And O1 it can answer anything. It might not be perfect for some tasks, but it's flexible, it has some richness to it, and this is kind of the art of how is a model a little bit undercooked? It's like, it's good to get a model out the door, but it's hard to gauge, and it takes a lot of taste to be like, is this a full-fledged model? Can I use this for everything? And they're probably more similar for math and code. My quick read is that Gemini Flash is like not trained the same way as O1, but taking an existing training stack, adding reasoning to it. So taking a more normal training stack and adding reasoning to it. And I'm sure they're going to have more. I mean, they've done quick releases on Gemini Flash, so reasoning, and this is the second version from the holidays. It's evolving fast, and it takes longer to make this training stack where you're doing this large scale.
Ask it the same question from earlier, the one about
the human nature.
Yeah.
What was the human nature one?
Why I can ramble about this so much is that we've been working on this at AI2 before O1 was fully available to everyone, and before R1, which is essentially using this RL training for fine-tuning. We use this in our Tulu series of models, and you can elicit the same behaviors where you say wait and such on, but it's so late in the training process that this kind of reasoning expression is much later. So there's essentially a gradation, and just how much of this RL training you put into it determines how the output looks.
So we're now using Gemini 2.0 Flash Thinking Experimental 121.
It summarized the prompt as humans self-domesticated apes.
Okay. All right. So wait, is this revealing the reasoning? Here's why this is novel. Okay.
Click to
Oh yeah,
expand.
click to expand.
Okay. Analyze the request. Novel is the keyword.
Like,
And-
see how it just looks a little different? It looks
It-
like a normal output.
Yeah, I mean, in some sense, it's better structured. It makes more sense.
Oh, when it latched onto human, and then it went into organisms, and oh wow.
Apex predator, focus on domestication, apply domestication to humans, explore the idea of self-domestication.
Not good. Not good.
Where is this going? Refine and articulate the insight, greater facial expressiveness and communication ability, yes. Plasticity and adaptability, yes. Dependence on social groups, yes. All right. And self-critique and refine further. Wow. Is this truly novel? Is it well supported? So on and so forth. And the insight is getting at is humans are not just social animals, but profoundly self-domesticated apes. And this self-domestication is the key to understanding our unique cognitive and social abilities. Self-domesticated apes.
I prefer the DeepSeek response.
I mean, it's novel. The insight is novel. I mean, that's like a good book title, Self-Domesticated Apes. Like there could be a case made for that. I mean, yeah, it's cool. And it's revealing the reasoning. It's magical. It's magical. Like this is really powerful. Hello, everyone. This is Lex with a quick intermission, recorded after the podcast. Since we reviewed responses from DeepSeek R1 and Gemini Flash 2.0 thinking during this conversation, I thought at this moment it would be nice to insert myself quickly doing the same for OpenAI O1 Pro and O3 Mini with the same prompt. The prompt being, give one truly novel insight about humans. And I thought I would, in general, give my vibe check and vibe-based anecdotal report on my own experiences with the new O3 Mini model, now that I got a chance to spend many hours with it in different kinds of contexts and applications. So I would probably categorize this question as, let's say, open-ended philosophical question. And in particular, the emphasis on novelty, I think is a nice way to test one of the capabilities of the model, which is come up with something that makes you pause and almost surprise you with its brilliance. So that said, my general review after running each of the models on this question a bunch of times is that O1 Pro consistently gave brilliant answers. Ones that gave me pause and made me think, both cutting in its insight and just really nicely phrased, with wit, with clarity, with nuance, over and over, consistently generating the best answers. After that is R1, which is less consistent, but again, delivered brilliance. Gemini Flash 2.0 thinking was third. And last was O3 Mini, actually. It often gave quite a generic answer, at least to my particular sensibilities. That said, in a bunch of other applications that I tested for brainstorming purposes, it actually worked extremely well and often outperformed R1. But on this open-ended philosophical question, it did consistently worse. Now, another important element for each of these models is how the reasoning is presented. DeepSeek R1 shows the full chain of thought tokens, which I personally just love. For these open-ended philosophical questions, it's really, really interesting to see the model think through it. But really also just stepping back, me as a person who appreciates intelligence and reasoning and reflection, reading these kind of chain of thought raw tokens of R1, there's something genuinely beautiful about observing the path of deliberation in an intelligence system. I think we don't always have that explicitly laid out for us humans. So to see it in another intelligence system, the nonlinearity of it, akin to Ulysses or Finnegan's Wake by James Joyce, it's just beautiful to watch. Anyway, as we discussed in the episode, DeepSeek R1 talked about humans being able to convert selfish desires into cooperative systems by collectively pretending abstract rules like money laws and rights are real, and these shared hallucinations act as games where competition is secretly redirected to benefit the group, turning conflict into society's fuel. Gemini 2.0 Flash Thinking said, humans are not just social animals, but self-domesticated apes. And this self-domestication is the key to understanding our unique cognitive and social abilities. Now, it's important to say that the chain of thought there was really interesting. It was looking through the entire evolution of life on Earth, considering apex predators, and considering how, from that, we ended up to where we are. I think that domestication by choice is a really interesting angle. Again, it's one of those things when somebody presents a different angle on a seemingly obvious thing, it just makes me smile. And the same with DeepSeek R1, with these hallucinations of money, laws, and rights, and us collectively pretending like it's real, and we play games with them that look like competition when secretly we're just cooperating with each other. And that is the fuel of progress. Beautifully put. Now, OpenAI O1 Pro consistently over and over delivered bangers. I can go through many of them, but the first one was humans are the only species that turns raw materials into symbolic resources, then uses those symbols to reorganize the very materials they came from, creating a closed feedback loop between meaning and matter. Here, I just ran it again. Banger after banger, I'm telling you. Humans are unique among known species in that they simultaneously rewrite two layers of reality, the external world and their own private mental landscapes, and then merge these two rewritten layers into a continuous personal narrative that feels objectively true. Feels true. This is poetry. Okay, and then O3 Mini High for me was smart, fast, actually, and kind of generic. Never quite got there for me. So here's the first one I got from O3 Mini. Humans are not fixed beings, but rather ongoing narratives, dynamic stories that we continuously write, edit, and reinterpret. This narrative plasticity is more than just memory or self-reflection. It's an intrinsic cognitive process that acts like an internal error correction system that allows us to adapt our identities and values over time in response to new experiences, challenges, and social contexts. Now it almost sneaks up to something approximating cutting insight with narrative plasticity in quotes. But then it goes back to the sort of the generic. I don't know. All of these models are incredible for different reasons. There's a lot of concerns as we discussed in this episode, but there's a lot of reasons to be excited as well. And I've probably spoken for too long. I am severely sleep deprived, borderline delirious, so hopefully some of this made sense. And now, dear friends, back to the episode.
I think when you to Nathan's point, when you look at like the reasoning models, to me, even when I used R1 versus O1, there was like that sort of rough edges around the corner feeling, right? And Flash Thinking, earlier, I didn't use this version, but the one from December, and it definitely had that rough edges around the corner feeling, right? Where it's just not fleshed out in as many ways, right? Sure, they added math and coding capabilities via these verifiers in RL, but it feels like they lost something in certain areas, and O1 is worse performing than chat in many areas as well, to be clear.
Not by a lot.
Not by a lot, though, right? And it's like like R1 definitely felt to me like it was worse than V3 in certain areas. Like doing this RL expressed and learned a lot, but then it weakened in other areas. And so I think that's one of the big differences between these models and what O1 offers. And then OpenAI has O1 Pro. And what they did with O3, which is like also very unique, is that they stack search on top of chain of thought, right? And so chain of thought is one thing where it's one chain, it backtracks, goes back and forth. But how they solved the Arc AGI challenge was not just the chain of thought. It was also sampling many times, i.e. running them in parallel and then selecting.
Is running in parallel actually search? Because I don't know if we have the full information on how O1 Pro works. So like I don't have enough information to confidently say that it is search.
It is parallel samples.
Yeah, and then
and
what?
It selects something.
And we don't know what the selection function The reason why we're debating is because since O1 was announced, there's been a lot of interest in techniques called Monte Carlo tree search, which is where you will break down the chain of thought into intermediate steps. We haven't defined chain of thought. Chain of thought is from a paper from years ago where you introduce the idea to ask a language model that at the time was much less easy to use. You would say, let's verify step by step, and it would induce the model to do this bulleted list of steps. Chain of thought is now almost a default in models, where if you ask it a math question, you don't need to tell it to think step by step. And the idea with Monte Carlo tree search is that you would take an intermediate point in that chain, do some sort of expansion, spend more compute, and then select the right one. That's like a very complex form of search that has been used in things like mu0 and AlphaZero potentially. I know mu0 does this.
Another form of search is just asking 5 different people and then taking the majority answer.
Yes.
Right. So there's a
Yeah.
variety of like, it could be complicated, it could be simple. We don't know what it is, just that they are not just issuing one chain of thought in sequence. They are launching many in parallel, and in the Arc AGI, they launched 1,000 in parallel for their the one that like really shocked everyone, that beat the benchmark, was they would launch 1,000 in parallel, and then they would get the right answer like 80% of the time or 70% of the time, 90 maybe even. Whereas if they just launched one, it was like 30%.
There are many extensions to this. I would say the simplest one is that our language models to date have been designed to give the right answer the highest percentage of the time in one response. And we are now opening the door to different ways of running inference on our models in which we need to reevaluate many parts of the training process, which normally opens the door to more progress, but we don't know if OpenAI changed a lot, or if just sampling more and multiple choice is what they're doing, or if it's something more complex where they change the training and they know that the inference mode is going to be different.
So we're talking about O1 Pro, $200 a month, and they're losing money. So the thing that we're referring to, this fascinating exploration of the test time compute space, is that actually possible? Do we have enough compute for that? Does the financials make sense?
So the fantastic thing is, and there, it's in the thing that I pulled up earlier, but the cost for GPT-3 has plummeted if you scroll up just a few images, I think. The important thing about like, hey, is cost a limiting factor here, right? Like my view is that like we'll have like really awesome intelligence before we have like AGI, before we have it permeate throughout the economy. And this is sort of why that reason is, right? GPT-3 was trained in what, 2020, 2021? And the cost for running inference on it was $60, $70 per million tokens, right? Which is the cost per intelligence was ridiculous. Now, as we scaled forward 2 years, we've had a 1200x reduction in cost to achieve the same level of intelligence as GPT-3.
So here on the x-axis is time over just a couple of years, and on the y-axis is log scale dollars to run inference on a million tokens.
Yeah, million.
And so you have just a down, like a linear decline on log scale from GPT-3 through 3.5 to Llama.
It's like 5 cents or something like that now, right? Which is versus
Yeah.
versus $60, 1200x. That's not the exact numbers, but it's 1200x. I remember that number. Is the humongous cost per intelligence, right? Now the freak out over DeepSeek is, oh my god, they made it so cheap. It's like, actually, if you look at this trend line, they're not below the trend line, first of all, and at least for GPT-3, right? They are the first to hit it, right? Which is a big deal. But they're not below the trend line as far as GPT-3. Now we have GPT-4. What's going to happen with these reasoning capabilities, right? It's a mix of architectural innovations, it's a mix of better data, and it's going to be better training techniques, and all of these different better inference systems, better hardware, right? Going from each generation of GPU to new generations or ASICs, everything is going to take this cost curve down and down and down and down. And then can I just spawn 1,000 different LLMs to create a task and then pick from one of them, or whatever search technique I want, a tree, Monte Carlo tree search? Maybe it gets that complicated. Maybe it doesn't because it's too complicated to actually scale. Like, who knows? Bitter lesson, right? The question is I think when, not if, because the rate of progress is so fast, right? 9 months ago, Dario was saying, Dario said 9 months ago the cost to train an inference was this, right? And now we're much better than this, right? And DeepSeek is much better than this. And that cost curve for GPT-4, which was also roughly $60 per million tokens, when it launched has already fallen to, you know, $2 or so, right? And we're gonna get it down to cents, probably, for GPT-4 quality. And the same, and then that's the base for the reasoning models like O1 that we have today. And O1 Pro is spawning more multiple, right? And O3 and, you know, so on and so forth. These search techniques too expensive today, but they will get cheaper, and that's what's gonna unlock the intelligence, right?
So it'll get cheaper and cheaper and cheaper. The big DeepSeek R1 release freaked everybody out because of the cheaper. One of the manifestations of that is Nvidia stock plummeted. Can you explain what happened? I mean, and also just explain this moment and whether, you know, if Nvidia is going to keep winning.
We're both NVIDIA bulls here, I would say, and in some ways the market response is reasonable. Most of the market, NVIDIA's biggest customers in the US are major tech companies, and they're spending a ton on AI. And if a simple interpretation of DeepSeek is you can get really good models without spending as much on AI. So in that capacity, it's like, oh, maybe these big tech companies won't need to spend as much on AI and go down. The actual thing that happened is much more complex, where there's social factors, where there's the rising in the App Store, the social contagion that is happening, and then I think a lot of some of it is just like, I don't trade, I don't know anything about financial markets, but it builds up over the weekend with the social pressure, where it's like, if it was during the week and there was multiple days of trading when this was really becoming, but it comes on the weekend and then everybody wants to sell, and that is a social contagion.
I think, and like there were a lot of false narratives, which is like, hey, these guys are spending billions on models, right? And they're not spending billions on models. No one spent more than $1 billion on a model that's released publicly, right? GPT-4 was a couple $100 million, and then, you know, they've reduced the cost with 4.0, 4 Turbo 4.0, right? But $1 billion model runs are coming, right? This includes pre-training and post-training, right? And then the other number is like, hey, DeepSeek didn't include everything, right? They didn't include, you know, a lot of the cost goes to research and all this sort of stuff. A lot of the cost goes to inference. A lot of the cost goes to post-training. None of these things were factored. Just research salaries, right? Like, all these things are like counted in the billions of dollars that OpenAI is spending, but they weren't counted in the, you know, hey, $6 million, $5 million that DeepSeek spent, right? So there's a bit of misunderstanding of what these numbers are. And then there's also an element of NVIDIA's just been a straight line up, right? And there's been so many different narratives that have been trying to push down NVIDIA. I don't say push down NVIDIA stock. Everyone is looking for a reason to sell or to be worried, right? You know, it was Blackwell delays, right? Their GPU was, you know, there's a lot of report. Every 2 weeks, there's a new report about their GPUs being delayed. There's the whole thing about scaling laws ending, right? It's so ironic, right?
It lasted a month.
It was just like literally just, hey, models aren't getting better, right? They're just not getting better. There's no reason to spend more. Pre-training scaling is dead, and then it's like O1, O3, right? R1, right? And now it's like, oh, wait, models are getting they're progressing too fast. Slow down the progress. Stop spending on GPUs, right?
Yeah.
But you know, the funniest thing I think that like comes out of this is Javon's paradox is true, right? AWS pricing for H100s has gone up over the last couple weeks, right? Since a little bit after Christmas, since V3 was launched, AWS H100 pricing has gone up. H200s are like almost out of stock everywhere because H200 has more memory, and therefore R1 wants that chip over H100, right?
We were trying to get GPUs on a short notice this week for a demo, and it wasn't that easy. We were trying to get just like 16 or 32 H100s for demo, and it was not very easy.
So for people who don't know, Javon's paradox is when the efficiency goes up, somehow magically, counterintuitively, the total resource consumption goes up as well.
Right, and semiconductors is, we're like 50 years of Moore's law. Every 2 years, half the cost, double the transistors. Just like clockwork, and it's slowed down obviously, but like the semiconductor industry has gone up the whole time, right? It's been wavy, right? There's obviously cycles and stuff, and I don't expect AI to be any different, right? There's going to be ebbs and flows, but this is, in AI, it's just playing out at an insane time scale, right? It was 2x every 2 years. This is 1200x in like 3 years, right? So it's like the scale of improvement that is like hard to wrap your head around.
Yeah, I was confused because to me, NVIDIA stock on that should have gone up. But maybe it went down because there's kind of suspicion of foul play on the side of China or something like this. But if you just look purely at the actual principles at play here, like, it's obvious. Yeah, Javon's
The more
paradox.
progress that AI makes, or the higher the derivative of AI progress is, especially, you should, because NVIDIA's in the best place. The higher the derivative is, the sooner the market's going to be bigger and expanding, and NVIDIA's the only one that does
Yeah,
everything
good.
reliably right now.
Because it's not like an NVIDIA competitor arose. It's another company that's using NVIDIA.
Who
So-
historically has been a large NVIDIA customer.
Yeah.
As
And has press releases about them cheering about being China's biggest Nvidia customer, right? Like,
Yeah, it
obviously they've quieted down, but like I think that's like another element of it is that they don't want to say how many GPUs they have,
Yeah.
because hey, they have H800s, yes they have H20s, they also have some H100s, right? Which
So-
were smuggled in.
Can you speak to that, to the smuggling? What's the scale of smuggling that's feasible for a nation state to do, for companies? Is it possible to?
I think there's a few angles of smuggling here, right? One is ByteDance arguably is the largest smuggler of GPUs for China, right? China's not supposed to have GPUs. ByteDance has like over 500,000 GPUs. Why? Because they're all rented from companies around the world. They rent from Oracle, they rent from Google, they rent from all these and a bunch of smaller cloud companies too, right? All the neo clouds, right, of the world. They rent so many GPUs. They also buy a bunch, right? And they do this for mostly like what Meta does, right? Serving TikTok, right? Serving next best, right?
Separate discussion.
Same as Meta, right? To be clear,
Yeah.
that's today the use, right? And it's a valid use, right? Hack the dopamine circuit, right? Now, that's theoretically now very much restricted with the AI diffusion rules, which happened in the last week of the Biden admin, and Trump admin looks like they're going to keep them, which limits like allies, even like Singapore, which Singapore is like 20% of NVIDIA's 30% of NVIDIA's revenue, but Singapore's had a moratorium on not building data centers for like 15 years because they don't have enough power. So where are they going? I mean, I'm not claiming they're all going to China, right? But a portion are, many are going to Malaysia, including Microsoft and Oracle have big data centers in Malaysia. Like, they're going all over Southeast Asia, probably India as well, right? Like, there's stuff routing, but like, the diffusion rules are very de facto. Like, you can only buy this many GPUs from this country, and you can only rent a cluster this large to companies that are Chinese, right? Like, they're very explicit on trying to stop smuggling, right? And a big chunk of it was, hey, let's random company buys 16 servers, ships them to China, right? There's actually, I saw a photo from someone in the semiconductor industry who leads like a team for like networking chips that competes with NVIDIA, and he sent a photo of a guy checking into a first-class United flight from San Francisco to Shanghai or Shenzhen with a super micro box that was this big, which can only contain GPUs, right? And he was booking first class, because think about it, 3 to 5K for your first class ticket, server costs, $240,000 in the US, $250,000, you sell it for $300,000 in China. Wait, you just got a free first class ticket and a lot more money. So it's like, and that's like small scale smuggling. Most of the large scale smuggling is like companies in Singapore and Malaysia, like routing them around or renting GPUs completely legally.
I want to jump in. How much is the scale? I think there's been some number, like some people that are higher level economics understanding say that like, as you go from 1 billion of smuggling to 10 billion, it's like you're hiding certain levels of economic activity, and that's the most reasonable thing to me, is that there's going to be some level where it's so obvious that it's easier to find this economic activity. And
yeah, so my belief is that last year roughly so NVIDIA made 1 million H20s, which are legally allowed to be shipped to China, which we talked about is better for reasoning, right? Inference at least, not training, but reasoning inference, and inference generally. Then they also had a couple 100,000, we think like 200 to 300,000 GPUs were routed to China from Singapore, Malaysia, US, wherever. Companies spawn up, buy 16 GPUs, 64 GPUs, whatever it is, route it. And Huawei's known for having spun up a massive network of like companies to get the materials they need after they were banned in like 2018, so it's not like otherworldly. But I agree, right? Nathan's point is like, hey, you can't smuggle up $10 billion of GPUs. And then the third sort of source, which is just now banned, which wasn't considered smuggling, but is China is renting, like, I believe from our research, right, Oracle's biggest GPU customer is ByteDance, right? And for Google, I think it's their second biggest customer. Right, and so like, and you go down the list of clouds, and especially these smaller cloud companies that aren't like the hyperscalers, right? Think beyond CoreWeave and Lambda, even there's a whole sea. There's 60 different new cloud companies serving NVIDIA GPUs. I think ByteDance is renting a lot of these, right? All over, right? And so these companies are renting GPUs to Chinese companies, and that was completely legal up until the diffusion rules, which happened just a few weeks ago. And even now, you can rent GPU clusters that are less than 2,000 GPUs, or you can buy GPUs and ship them wherever you want if they're less than 1,500 GPUs, right? So it's like there are still like some ways to smuggle, but yeah, it's not, as the numbers grow, right? 100-something billion of revenue for NVIDIA last year, 200-something billion this year, right? And if next year it could nearly double again or more than double, right? Based on like what we see with data center footprints like being built out all across the US and the rest of the world, it's going to be really hard for China to keep up with these rules, right? Yes, there will always be smuggling, and DeepSeek level models and GPT-4 level models, O1 level models, capable to train on what China can get, even the next tier above that. But if we speed run a couple more, jumps, right, to billion-dollar models, $10 billion models, then it becomes, hey, there is a compute disadvantage for China for training models and serving them. And the serving part is really critical, right? DeepSeek cannot serve their model today, right? It's completely out of inventory. It's already started falling in the App Store, actually, downloads, because you download it, try and sign up. They say we're not taking registrations because they have no capacity, right? You open it up, you get like less than 5 tokens per second if you even get your request approved, right? Because there's just no capacity because they just don't have enough GPUs to serve the model, even though it's incredibly efficient.
It would be fascinating to watch the smuggling, because I mean, there's drug smuggling, right? That's a market. There's weapons smuggling, and GPUs will surpass that at some point.
Chips are highest value per kilogram, probably by far. I have another question for you, Dylan. Do you track model API access internationally? How easy is it for Chinese companies to use hosted model APIs from the US?
Yeah, I mean, that's incredibly easy, right? Like, OpenAI publicly stated DeepSeek uses their API, and as they say, they have evidence, right? And this is another element of the training regime, is people at OpenAI have claimed that it's a distilled model, i.e. you're taking OpenAI's model, you're generating a lot of output, and then you're training on the output in their model. And even if that's the case, what they did is still amazing, by the way, what DeepSeek did efficiency-wise.
Distillation is standard practice in industry, whether or not, if you're at a closed lab where you care about terms of service and IP closely, you distill from your own models. If you are a researcher and you're not building any products, you distill from the OpenAI model.
This is a good opportunity. Can you explain big picture distillation as a process? What is distillation? What's the process of distillation?
Talked a lot about training language models. They are trained on text. In post-training, you're trying to train on very high-quality text that you want the model to match the features of, or if you're using RL, you're letting the model find its own thing. But for supervised fine-tuning, for preference data, you need to have some completions what the model is trying to learn to imitate. And what you do there is, instead of a human data or instead of the model you're currently training, you take completions from a different, normally more powerful model. I think there's rumors that these big models that people are waiting for, these GPT-5s of the world, the Claude 3 opuses of the world, are used internally to do this distillation process at
There's also
OpenAI.
public examples, right? Like Meta explicitly stated, not necessarily distilling, but they used 405B as a reward model for 70B in their Llama 3.2
Yeah.
or 3.3.
This is all the same topic.
So is this ethical? Is this legal? Like, why is that Financial Times article headline say OpenAI says that there's evidence that China's DeepSeek used its model to train competitors?
This is a long, at least in the academic side and research side, has a long history because you're trying to interpret OpenAI's rule. OpenAI's terms of service say that you cannot build a competitor with outputs from their model. Terms of service are different than a license, which are essentially a contract between organizations. So if you have a terms of service on OpenAI's account, if I violate it, OpenAI can cancel my account. This is very different than like a license that says how you could use a downstream artifact. So a lot of it hinges on a word that is very unclear in the AI space, which is what is a competitor.
And
so,
and then the ethical aspect of it is like, why is it unethical for me to train on your model when you can train on the internet's text?
Yeah.
Right?
So there's a bit of a hypocrisy because sort of OpenAI and potentially most of the companies trained on the internet's text without permission.
There's also a clear loophole, which is that I generate data from OpenAI and then I upload it somewhere and then somebody else trains on it and the link has been broken. Like they're not under the same terms of service contract.
This is
why there's a lot of there's a lot of like to be discovered details that don't make a lot of sense.
This is why a lot of models today, even if they train on zero OpenAI data, you ask the model who trained you, it'll say I am ChatGPT trained by OpenAI, because there's so much copy paste of like OpenAI outputs from that on the internet that you just weren't able to filter it out, and there was nothing in the RL where they implemented like, hey, like, or post training or SFT, whatever, that says, hey, I'm actually modeled by Allen Institute instead of
We
OpenAI.
have to do this if we serve a demo. We do research and we use OpenAI APIs because it's useful, and we want to understand post training, and like our research models, they will say they're written by OpenAI unless we put in the system prompt that we talked about, that like, I am Tulu, I am a language model trained by the Allen Institute for AI. And if you ask more people around industry, especially with post-training, it's a very doable task to make the model say who it is or to suppress the OpenAI thing. So in some levels, it might be that DeepSeek didn't care that it was saying that it was by OpenAI. Like, if you're going to upload model weights, it doesn't really matter, because anyone that's serving it in an application and cares a lot about serving is going to, when serving it, if they're using it for a specific task, they're going to tailor it to that. It doesn't matter that it's saying it's ChatGPT.
Oh, I guess one of the ways to do that is like a system prompt or something like that. Like if you're serving it to say that you're.
That's what we do. Like if we host a demo, you say you are Tulu 3, a language model trained by the Allen Institute for AI. We also are benefited from OpenAI data because it's a great research tool.
I mean, do you think there's any truth and value to the claim, OpenAI's claim, that there's evidence that China's DeepSeek uses models to train?
I think everyone has benefited regardless, because the data's on the internet, and therefore it's in your per-training node, right? There are like subreddits where people share the best ChatGPT outputs, and those are in your.
I think that
model
they're
pre-
trying to shift the narrative. Like, they're trying to protect themselves, and we saw this years ago when ByteDance was actually banned from some OpenAI APIs for training on outputs. There's other AI startups that most people, if you're in the like AI culture, were like, they just told us they trained on OpenAI outputs and they never got banned. Like, that's how they bootstrapped their early models. So it's much easier to get off the ground using this than to set up human pipelines and build a strong model. So there's a long history here, and a lot of the communications seem like narratives.
Actually, like over the last couple of days, we've seen a lot of people distill DeepSeek's model into Llama models, because the DeepSeek models are kind of complicated to run inference on, because they're a mixture of experts, and they're 600 plus billion parameters and all this, and people distilled them into the Llama models, and then because the Llama models are so easy to serve, and everyone's built the pipelines and tooling for inference with the Llama models, right? Because it's the open standard. So we've seen a sort of roundabout, right? Like, is it bad? Is it illegal? Maybe it's illegal, whatever. I don't know about that, but like,
It could break contracts. I don't think it's illegal. Like in any legal, like no one's going to jail for this. Ever.
I think like fundamentally, I think it's ethical, or I hope it's ethical, because like if the moment it becomes, we ban that kind of thing, it's gonna make everybody much worse off. And I also actually, this is difficult, but I think you should be allowed to train on the internet. I know a lot of authors and creators are very sensitive about it. That's a difficult question. But like the moment you're not allowed to train on the internet.
I agree.
I have a schizo take on how you can solve this, because
right.
it already works.
I have a reasonable take on it.
Right?
All right.
So Japan has a law which you're allowed to train on any training data, and copyrights don't apply if you want to train a model. A. B. Japan has 9 gigawatts of curtailed nuclear power. C. Japan is allowed under the AI diffusion rule to import as many GPUs as they'd like. So all we have to do, we have a market here to make. We build massive data centers, we rent them to the labs, and then we train models in a legally permissible way, and there's no ifs, ands, or buts. And now the models have no like potential copyright lawsuit from New York Times or anything like that. No, it's just like completely legal. No, so
Genius.
The early copyright lawsuits have fallen in favor of AI training. I would say that the long tail of use is going to go in the side of AI, which is if you scrape trillions of data, you're not looking at the trillions of tokens of data, you're not looking and saying this one New York Times article is so important to me. But if you're doing a audio generation for music or image generation and you say make it in the style of X person, that's a reasonable case where you could figure out what is their profit margin on inference. I don't know if it's going to be the 50-50 of YouTube creator program or something, but I would opt into that program as a writer. Like, please, like that. It's going to be a rough journey, but there will be some solutions like that make sense. But there's a long tail where it's just on the internet.
I think one of the other aspects of that Financial Times article implied, and so that leads to a more general question. Do you think there's how difficult is spying, espionage, and stealing of actual secret code and data from inside companies? How much of that is being attempted?
Code and data is hard, but ideas is easy. Silicon Valley operates
Yeah.
on the way that top employees get bought out by other companies for a pay raise, and a large reason why these companies do this is to bring ideas with them. And there's no, I mean, in California, there's rules that like certain like non-competes or whatever are illegal in California, and whether or not there's NDAs and things, that is how a lot of it happens. And recently, there was somebody from Gemini who helped make this 1 million context length, and everyone is saying the next llama, who, I mean, he went to the meta team, is gonna have 1 million context length, and that's kind of how the world works.
You know, as far as like industrial espionage and things, that has been greatly successful in the past, right? You know, the Americans did it to the Brits, the Chinese have done it to the Americans, right? And you know, so on and so forth. It is a fact of life. And so like to argue industrial espionage can be stopped is probably unlikely. You can make it difficult, but even then, like there's all these stories about like, hey, F-35 and F-22 have already been like sort of like given to China in terms of design plans and stuff. Code and stuff like between, you know, I say companies, not nation states, is probably very difficult. But ideas are discussed a lot, right? Whether it be a house party in San Francisco, or a company changing employees, or you know, or the always the like mythical honeypot that always gets talked about, right? Like someone gets honeypotted, right? Because everyone working on AI is a single dude who's in their 20s and 30s. Not everyone, but like an insane amount of insane percentages. So there's always like all these like, you know, and obviously.
So honeypotted is like a spy, a female spy approaches you and like.
Yeah.
Yeah, or male, right? You know, it's San Francisco, right? But you know, as a single dude, I will say, in his late 20s, right, is like we are very easily corrupted, right? Like you know, like not corrupted myself, but you know, like we are, right?
Everybody else, not me.
Yeah,
Everybody
exactly.
I'm too oblivious and I am not single, so I'm safe from one espionage axis.
Yeah, you have to make sure to close all security vulnerabilities. So you, Dylan, collect a lot of information about each of the mega clusters for each of the major AI companies. Can you talk about the build outs for each one that stand out?
Yeah, so I think the thing that's like really important about these mega cluster build-outs is they're completely unprecedented in scale, right? US, you know, sort of like data center power consumption has been slowly on the rise, and it's gone up to 2-3% even through the cloud computing revolution, right? Data center consumption as a percentage of total US. And that's been over decades, right, of data centers, et cetera. It's been climbing slowly. But now, 2 to 3%. Now, by the end of this decade, it's like even under like, you know, when I say like 10%, a lot of people that are traditionally by like 2028, 2030, people traditionally traditional data center people like that's nuts. But then like people who are in like AI who have like really looked at this at like the Anthropics and OpenAIs are like that's not enough. Okay, but like you know this is both through globally distributed or distributed throughout the U.S. as well as like centralized clusters, right? The distributed throughout the U.S. is exciting and it's the bulk of it, right? Like hey, you know OpenAI or you know say Meta's adding a gigawatt, right? But most of it is distributed through the U.S. for inference and all these other things, right?
So maybe we should lay out what a cluster is. So, you know, does this include AWS? Maybe it's good to talk about the different kinds of clusters and what you mean by mega clusters and what's a GPU and what's a computer and what. Not that far back, but yeah. So like, what do we mean by the clusters?
Oh
the
man,
build-outs?
I thought I was about to do the Apple ad, right? What's a computer? So traditionally, data centers and data center tasks have been a distributed systems problem that is capable of being spread very far and widely, right? I.e., I send a request to Google, it gets routed to a data center somewhat close to me, it does whatever search ranking recommendation, sends a result back, right? The nature of the task is changing rapidly in that there's two tasks that people are really focused on now, right? It's not database access, it's not serve me the right page, serve me the right ad. It's now inference, and inference is dramatically different from traditional distributed systems, but it looks a lot more similar. And then there's training, right? The inference side is still like, hey, I'm going to put thousands of GPUs in blocks all around these data centers. I'm going to run models on them. User submits a request, gets kicked off, or hey, my service, they submit a request to my service, right? They're on Word, and they're like, oh yeah, help me Copilot, and it starts kicks it off. I'm on my Windows, Copilot, whatever, Apple Intelligence, whatever it is, it gets kicked off to a data center, right? And that data center does some work and sends it back. That's inference. That is going to be the bulk of compute. But then, and that's like, there's thousands of data centers that we're tracking with like satellites and like all these other things. And those are the bulk of what's being built. But the scale of, and so that's like what's really reshaping, and that's what's getting millions of GPUs. But the scale of the largest cluster is also really important, right? When we look back at history, right, like, or through the age of AI, right? Like, it was a really big deal when they did AlexNet on, I think, 2 GPUs or 4 GPUs? I don't remember. It was a really big deal.
It's a big deal because you use GPUs.
It's a big deal they use GPUs, and they used multiple, right? But then over time, its scale has just been compounding, right? And so when you skip forward to GPT-3, then GPT-4, GPT-4, 20,000 A100 GPUs. Unprecedented run, right? In terms of the size and the cost, right? A couple $100 million on a YOLO, right? A YOLO run for GPT-4, and it yielded, this magical improvement that was like perfectly in line with what was experimented and just like a log scale, right?
Oh yeah, they have that plot from the paper. The technical report.
The scaling laws were perfect, right? But that's not a crazy number, right? 20,000 A100s, roughly each GPU is consuming 400 watts, and then when you add in the whole server, right, everything, it's like 15 to 20 megawatts of power, right? Maybe you could look up what the power of consumption of a person is, because the numbers are going to get silly. But like, 15 to 20 megawatts was standard data center size. It was just unprecedented. That was all GPUs running one task.
Lots of the toaster.
Yeah, so a toaster is like
It's a good example.
A similar power consumption to an A100, right? H100 comes around, they increase the power from like 400 to 700 watts, and that's just per GPU, and then there's all the associated stuff around it. So it's just, once you count all that, it's roughly like 1,200 to 1,400 watts for everything, networking, CPUs, memory, blah, blah, blah.
So we should also say, so what's required? You said power, so a lot of power is required, a lot of heat is generated, so cooling is required, and because there's a lot of GPUs that have to be, or CPUs or whatever, they have to be connected, so there's a lot of networking.
Yeah,
right.
So I think, sorry for skipping past that. And then the data center itself is like complicated, right? But these are still standardized data centers for GPT-4 scale, right? Now we step forward to sort of what is the scale of clusters that people built last year, right? And it ranges widely, right? It ranges from like, hey, these are standard data centers, and we're just using multiple of them and connecting them together, really, with a ton of fiber between them, a lot of networking, etc. That's what OpenAI and Microsoft did in Arizona, right? So they have 100,000 GPUs, right? Meta, similar thing. They took their standard existing data center design, and it looks like an H, and they connected multiple of them together. And they first did 16,000 GPUs, 24,000 GPUs total. Only 16,000 of them were running on the training run because GPUs are very unreliable, so they need to have spares to like swap in and out. All the way to like now 100,000 GPUs that they're training on Llama 4 on currently, right? Like 128,000 or so, right? This is, think about 100,000 GPUs with roughly 1,400 watts a piece. That's 140 megawatts, 150 megawatts, right? Or 128, right? So you're talking about, you've jumped from 15 to 20 megawatts to 10x, almost 10x that number, 9x that number, 150 megawatts in 2 years, right? From 2022 to 2024, right? And some people like Elon, he admittedly, right, and he says it himself, got into the game a little bit late for pre-training large language models, right? XAI was started later, right? But then he bet heaven and hell to get his data center up and get the largest cluster in the world, right? Which is 200,000 GPUs. And he did that. He bought a factory in Memphis. He's upgrading the substation, but at the same time, he's got a bunch of mobile power generation, a bunch of single cycle combine. He tapped the natural gas line that's right next to the factory and is just pulling a ton of gas, burning gas. He's generating all this power. He's in a factory, in an old appliance factory that's shut down and moved to China long ago, right? Like, and he's got 200,000 GPUs in it. And now what's the next scale, right? Like all the hyperscalers have done this. Now the next scale is something that's even bigger, right? And so, Elon, just to stick on the topic, he's building his own natural gas plant, like a proper one, right next door. He's deploying tons of Tesla Megapack batteries to make the power more smooth, and all sorts of other things. He's got like industrial chillers to cool the water down because he's water cooling the chips. So all these crazy things to get the clusters bigger and bigger. But when you look at, like, say what OpenAI did with Stargate, that's that in Arizona, in Abilene, Texas, right? What they've announced, at least, right? It's not built, right? Elon says they don't have the money. You know, there's some debates about this. But at full scale, at least the first section is like definitely money's accounted for, but there's multiple sections. But full scale, that data center is going to be 2.2 gigawatts, right? 2,200 megawatts of power in, and roughly like 1.8 gigawatts or 1,800 1,800 megawatts of power delivered to chips, right? Now, this is an absurd scale. 2.2 gigawatts is like more than most cities, right? You know, to be clear, and delivered to a single cluster that's connected to do training, right? To train these models, to do both the pre-training, the post-training, all of this stuff, right?
This is insane.
It is.
This is
What is
insane.
a nuclear power plant
And
again?
everyone is doing this, right? Everyone is doing this, right? Meta in Louisiana, right? They're building 2 natural gas plants, massive ones, and then they're building this massive data center. Amazon has like plans for this scale. Google has plans for this scale. XAI has plans for this scale, right? Like all of these, the guys that are racing, the companies that are racing hard, and they're doing multi-gigawatt data centers, right? To build this out because they think that, yeah, if I now have, you know, obviously pre-training scaling is going to continue, but to some extent, but then also all this post-training stuff where you have a RL sandbox for computer use or whatever, right? Like, you know, this is where they're going to, and all these viable domains where they just keep learning and learning and learning, self-play, whatever it is, makes the AI so much more capable because the line does go up, right? As you throw more compute, you get more performance. The shirt is about scaling laws. You know, to some extent, it is diminishing returns, right? You 10x the compute, you don't get 10x better model, right? You get a diminishing returns, but also you get efficiency improvements, so you bend the curve, right? And these scale of data centers are doing, you know, wreaking, you know, a lot of like havoc on the network, right? And, you know, Nathan was mentioning there's Amazon has tried to buy this nuclear power plant, Talon, and if you look at Talon stock, it's just like skyrocketing, and you know, like they're building a massive multi-gigawatt data center there, and you know, you just go down the list. There's so many ramifications. Interesting thing is like certain regions of the U.S. transmitting power cost more than actually generating it, right? Because the grid is so slow to build, and the demand for power and the ability to build power and like re-ramping on a natural gas plant or even a coal plant is like easy enough to do, but like transmitting the power is really hard. So in some parts of the US, like in Virginia, it costs more to transmit power than it costs to generate it. Which is like, you know, there's all sorts of like second order effects that are insane here.
Can the power grid support this kind of growth?
You know, Trump's executive orders, there was a Biden executive order before the end of the year, but then Trump had some more executive orders, which hopefully reduce the regulations to where, yes, things can be built. But yeah, this is a big challenge, right? Is building enough power fast enough.
Are you going to basically have a nuclear power plant next to a data center for each one of these?
So the fun thing here is this is too slow.
To build the power plant.
To build a power plant or to reconfigure an existing power plant is too slow. And so therefore you must use data center power consumption is flat, right? You know, I mean, like it's spiky,
Which is
right?
why nuclear is also good for it. Like long-term, nuclear is a very natural fit, but
Yeah,
you can't do solar or anything in the short term like that.
because data center power is like this, right? Like you're telling me, you know, I'm gonna buy tens of billions of dollars of GPUs and idle them because the power's not being generated. Like power is cheap, right? Like if you look at the cost of a cluster, less than 20% of it is power, right? Most of it is the capital cost and depreciation of the GPUs, right? And so it's like, well, screw it. I'll just like, you know, I'll just build natural gas plants. This is what Meta's doing in Louisiana. This is what OpenAI is doing in Texas and like all these different places. They may not be doing it directly, but they are partnered with someone. And so there is a couple hopes, right? Like one is, you know, and Elon, what he's doing in Memphis is like, you know, to the extreme. They're not just using dual combined cycle gas, which is like super efficient. He's also just using single cycle and like mobile generators and stuff, which is less efficient. But he's, you know, there's also like the flip side, which is like solar power generation is like this, and wind is another like this, different correlate, you know, different. So if you stack both of those, plus you get a big chunk of batteries, plus you have a little bit of gas, it is possible to run it more green. It's just the time scales for that is slow, right? So people are trying, but you know, Meta basically said, whatever, don't care about my sustainability pledge, or they'll buy like a power. It's called a PPA, power purchasing agreement, where there'll be a massive wind farm or solar farm, like wherever, and then they'll just pretend like those electrons are being consumed by the data center, but in reality, they're paying for the power here and selling it to the grid, and then they're buying power here. And then another thing is like Microsoft quit on some of their sustainability pledges, right? Elon, what he did with Memphis is objectively somewhat dirty, but he's also doing it in an area where there's like a bigger natural gas plant right next door and like a sewer or not a sewer, but like a wastewater treatment and a garbage dump nearby, right? And he's obviously made the world a lot more clean than that one data center is gonna do, right? So I think like it's fine to some extent, and maybe AGI solves global warming and stuff, right? Whatever it is, this is sort of the attitude that people at the labs have, right? Which is like, yeah, screw it, we'll just use gas, right? Because the race is that important, and if we lose, that's way worse, right?
I should say that I got a chance to visit the Memphis data center,
wow.
and it's kind of incredible. I mean, I visited with Elon. Just the teams and the rate of innovation there is insane. Because my sense is that nobody's ever done anything of this scale, and nobody has certainly ever done anything of this scale at the rate that XAI is doing. So they're like figuring out. I mean, and so I was sitting in on all these meetings where they're brainstorming. It's like it's insane. It's exciting because they're trying to figure out what the bottlenecks are, how to remove the bottlenecks, how to make sure that there's just so many really cool things about putting together a data center. Because everything has to work. It's the people that do like the sysadmin, the machine learning, all that is the exciting thing, so on. But really, the people that run everything are the folks that know like the low level software and hardware that runs everything, the networking, all of that. And so you have to like make sure you have procedures that test everything. I think they're using Ethernet. I don't know how they're doing the networking, but
they're using NVIDIA's Spectrum-X Ethernet. There's actually I think the unsung heroes are the cooling and electrical systems, which are just like glossed over.
Yeah.
But I think like one story that maybe is like exemplifies how insane this stuff is when you're training, right? You're always doing you're running through the model a bunch, right? In the most simplistic terms, running through the model a bunch. And then you're going to exchange everything and synchronize the weights, right? So you'll do a step. This is like a step in model training, right? At every step, your loss goes down, hopefully, and it doesn't always. But in the simplest terms, you'll be computing a lot, and then you'll exchange, right? The interesting thing is GPU power is most of it. Networking power is some, but it's a lot less. But so while you're computing, your power for your GPUs is here. But then when you're exchanging weights, if you're not able to overlap communications and compute perfectly, there may be a time period where your GPUs are just idle and you're exchanging weights and you're like, hey, the model's updating. So you're exchanging the gradients, you do the model update, and then you start training again. The power goes, right? And it's super spiky. And so funnily enough, right, like this, when you talk about the scale of data center power, right, you can blow stuff up so easily. And so Meta actually has accidentally upstreamed something to code in PyTorch where they added an operator, and I kid you not, whoever made this, like I want to hug the guy because it says PyTorch, it's like PyTorch.powerplant no blow up equals 0 or equal 1, and what it does is amazing, right?
Yeah.
Either when you're exchanging the weights, the GPU will just compute fake numbers, so the power doesn't spike too much, and so then the power plants don't blow up because the transient spikes like screw stuff up.
Well, that makes sense. I mean, you have to do that kind of thing. You have to make sure they're not idle. Yeah.
And Elon's solution was like, let me throw a bunch of Tesla mega packs and a few other things, right? Like, everyone has different solutions, but like Meta's at least was public and openly known, which is just like set this operator, and what this operator does is it just makes the GPUs compute nothing, so that the power doesn't spike.
But that just tells you how much power you're working with. I mean, it's insane. It's insane.
People should just go to Google, like, scale, like, what does X watts do, and go through all the scales from 1 watt to a kilowatt to a megawatt. And you look and stare at that, and you're how high on the list a gigawatt is, and it's mind-blowing.
Can you say something about the cooling? So I know Elon's using liquid cooling, I believe, in all cases. That's a new thing, right? Most of them don't use liquid cooling. Is there something interesting to say about the cooling?
Yeah. So air cooling has been the de facto standard. Throw a bunch of metal, heat pipes, etc., and fans, right? And like that's cooled. That's been enough to cool it. People have been dabbling in water cooling. Google's TPUs are water cooled, right? So they've been doing that for a few years. But with GPUs, no one's ever done, and no one's ever done the scale of water cooling that Elon just did, right? Now, next generation NVIDIA is for the like highest end GPU, it is mandatory water cooling. You have to water cool it. But Elon did it on this current generation, and that required a lot of stuff, right? If you look at like some of the satellite photos and stuff of the Memphis facility, there's all these external water chillers that are sitting basically. It looks like a semi-truck pod thing. What's it called? The container. But really, those are water chillers, and he has like 90 of those water chillers just sitting outside. 90 different containers, right, with water, that chill the water. Bring it back to the data center, and then you distribute it to all the chips, pull all the heat out, and then send it back, right? And this is both a way to cool the chips, but also an efficiency thing. All right, and going back to that like sort of 3-vector thing, right? There is memory bandwidth, flops, and interconnect. The closer the chips are together, the easier it is to do high-speed interconnects, right? And so this is also like a reason why you're gonna go water cooling, is because you can just put the chips right next to each other and therefore get higher speed connectivity.
I gotta ask you. So in one of your recent posts, there's a section called cluster measuring contest. So
there's another word there, but I won't say it.
Who's got the biggest now, and who's gonna have the biggest?
Today, individual largest is Elon, right?
Elon's cluster.
Elon's cluster in Memphis, 200,000 GPUs, right? Meta has like 128,000. OpenAI has 100,000 now. Now, to be clear, other companies have more GPUs than Elon. They just don't have them in one place, right? And for training, you want them tightly connected. There's some techniques that people are researching and working on that let you train across multiple regions, but for the most part, you want them all in like one area, right? So you can connect them with high-speed networking. And so, Elon today has 200,000 H100s and 100,000 H100s, 100,000 H200s, right? Meta, OpenAI, and Amazon all have on the scale of 100,000, a little bit less. But this year, people are building much more, right? Anthropic and Amazon are building a cluster of 400,000 Trainium 2, which is Amazon's specific chip, trying to get away from NVIDIA, right? Meta and OpenAI have scales for hundreds of thousands, but by next year, you'll have like 500,000 to 700,000 GPU clusters. And note, those GPUs are much higher power consumption than existing ones, right? Hopper's 700 watts, Blackwell goes to 1,200 watts, right? So the power per chip is growing, and the number of chips is growing, right?
Nuts. You think Elon said you'll get to 1 million? You think that's actually feasible?
I mean, I don't doubt Elon, right? The filings that he has for the power plant and the Tesla battery packs, it's clear he has some crazy plans for Memphis. Like permits and stuff is open record, right? But it's not quite clear that what the timescales are. I just never doubt Elon, right? It's gonna surprise me.
So what's the idea with these clusters? If you have 1 million GPUs, what percentage in let's say 2-3 years is used for training, and what percent pre-training, and what percent is used for the actual computation?
So these mega clusters make no sense for inference, right? You could route inference there and just not train. But most of the inference capacity is being, hey, I've got a 30 megawatt data center here, I've got 50 megawatts here, I've got 100 here, whatever. I'll just throw inference in all of those, because the mega clusters, right, multi-gigawatt data centers, I want to train there, because that's where all of my GPUs are co-located, where I can put them at a super high networking speed connected together, right? Because that's what you need for training. Now, with pre-training, this is the old scale, right? You would increase parameters, you'd increase data, model gets better. That doesn't apply anymore, because there's not much more data in the pre-training side, right? Yes, there's video and audio and image that has not been fully taken advantage of, so there's a lot more scaling. But a lot of people have taken transcripts of YouTube videos, and that gets you a lot of the data. It doesn't get you all of the learning value out of the video and image data, but there's still scaling to be done on pre-training. But this post-training world is where all the flops are going to be spent, right? The model's going to play with itself. It's going to self-play. It's going to do verifiable tasks. It's going to do computer use in sandboxes. It might even do simulated robotics things, right? All of these things are going to be environments where compute is spent in quote-unquote post-training. But I think it's going to be good. We're gonna drop the post from post-training. Yeah, it's gonna be pre-training and it's gonna be training, I think.
Return of the King.
At some point, because for the bulk of the last few years, pre-training has dwarfed post-training. but with these verifiable methods, especially ones that scale really, potentially infinitely, like computer use and robotics, not just math and coding, right, where you can verify what's happening, those infinitely verifiable tasks, it seems you can spend as much compute as you want on them.
Especially with context length increase, because at the end of pre-training is when you increase the context length for these models, and we've talked earlier in the conversation about how the context length, when you have a long input, is much easier to manage than output, and a lot of these post-training and reasoning techniques rely on a ton of sampling, and it's becoming increasingly long context. So it's just like effectively your compute efficiency goes down. I think flops is the standard for how you measure it, but with RL and you have to do all these things where you move your weights around in a different way than at pre-training and just generation, it's going to become less efficient, and flops is going to be less of a useful term. And then as the infrastructure gets better, it's probably going to go back to flops.
So all of the things we've been talking about is most likely going to be NVIDIA, right? Is there any competitors?
Google, I kind of
GPU.
ignored them.
What's the story with TPU? What's the story with TPU? Like, what's the...
TPU is awesome, right? It's great. Google they're a bit more tepid on building data centers for some reason. They're building big data centers, don't get me wrong. And they actually have the biggest cluster. I was talking about NVIDIA clusters. They actually have the biggest cluster, period. But the way they do it is like very interesting, right? They have two sort of like data center super regions, right? In that the data center isn't physically, like all of the GPUs aren't physically on one site, but they're like 30 miles from each other. Or not GPUs, TPUs, right? They have like in Iowa and Nebraska, they have 4 data centers that are just like right next to each other.
Why doesn't Google flex its cluster size?
Go to
more often?
multi-data center training. There's some good images in there, so I'll show you what I mean. It's just semi-analysis multi-data center. So this is like, so this is an image of like what a standard Google data center looks like. By the way, their data centers look very different than anyone else's data centers.
What are we looking at here?
So these are, so if you see this image, right, in the center there are these big rectangular boxes, right? Those are where the actual chips are kept. And then if you scroll down a little bit further, you can see there's like these water pipes, there's these chiller cooling towers in the top, and a bunch of like diesel generators. The diesel generators are backup power. The data center itself is look physically smaller than the water chillers, right? So the chips are actually easier to like keep together, but then like cooling all the water for the water cooling is very difficult, right? So Google has like a very advanced infrastructure that no one else has for the TPU. And what they do is they've stamped a bunch of these data centers out in a few regions, right? So if you go a little bit further down, this is a Microsoft. This is in Arizona. This is where GPT-5 quote unquote will be trained.
If it doesn't exist already.
Yeah, if it doesn't exist already. But each of these data centers, right? I've shown a couple images of them. They're really closely co-located in the same region, right? Nebraska, Iowa, and then they also have a similar one in Ohio complex, right? And so these data centers are really close to each other. And what they've done is they've connected them super high bandwidth with fiber. And so these are just a bunch of data centers. And the point here is that Google has a very advanced infrastructure, very tightly connected in a small region. So Elon will always say have the biggest cluster fully connected, right? Because it's all in one building, right? And he's completely right on that, right? Google has the biggest cluster, but you have to spread over 3 sites, and by a significant margin, we have to go across multiple sites.
Why doesn't Google compete with NVIDIA? Why don't they sell TPUs?
I think there's a couple problems with it. It's like, one, TPU has been a form of allowing search to be really freaking cheap and build models for that, right? And so like a big chunk of the search GPU purchases or TPU purchases, or a big chunk of Google's purchases and usage, all of it is for internal workloads, right? Whether it be search, now Gemini, right? YouTube, all these different applications that they have, ads. These are where all their TPUs are being spent, and that's what they're hyper-focused on, right? And so there's certain aspects of the architecture that are optimized for their use case that are not optimized elsewhere, right? One simple one is they've open sourced the Gemma model, and they called it Gemma 70, right? But then it's actually 8 billion parameters because the vocabulary is so large. And the reason they made the vocabulary so large is because TPU's matrix multiply unit is massive. Because that's what they've sort of optimized for. And so they decided, oh, well, I'll just make the vocabulary large too, even though it makes no sense to do so on such a small model, because that fits on their hardware. So Gemma doesn't run as efficiently on a GPU as a Llama does, right? But vice versa, Llama doesn't run as efficiently on a TPU as a Gemma does, right? And it's so like there's like certain like aspects of like hardware software co-design. So all their search models are their ranking and recommendation models, all these different models that are AI but not like Gen AI, right? Have been hyper optimized with TPUs forever. The software stack is super optimized, but all of this software stack has not been released publicly at all, right? Very small portions of it. JAX and XLA have been, but like the experience when you're inside of Google and you're training on TPUs as a researcher, you don't need to know anything about the hardware in many cases, right? Like it's like pretty beautiful. But as soon as you step outside,
they all go. A lot of them go back. They leave Google and then they go back.
Yeah.
yeah, they're like they leave and they start a company because they have all these amazing research ideas. And they're like, wait, infrastructure is hard, software is hard, and this is on GPUs. Or if they try to use TPUs, same thing because they don't have access to all this code. And
Right.
so it's like, how do you convince a company whose golden goose is search, where they're making hundreds of billions of dollars from, to start selling GPU or TPUs, which they used to only buy a couple billion of. I think in 2023 they bought like a couple billion. And now they're buying like $10 billion to $15 billion worth. But how do you convince them that they should just buy like twice as many and figure out how to sell them and make $30 billion? Like, who cares about making $30 billion?
Won't that 30 billion exceed actually the search profit eventually?
I mean, like, you're always going to make more money on services.
Always.
Or, I mean, like, yeah, like to be clear, like today people are spending a lot more on hardware than they are the services, right? Because the hardware front runs the service spend. But like,
You're investing. Yeah.
if there's no revenue for AI stuff or not enough revenue, then obviously like it's going to blow up, right? People won't continue to spend on GPUs forever. And NVIDIA is trying to move up the stack with like software that they're trying to sell and license and stuff, right? But Google has never had that like DNA of like, this is a product we should sell, right? They don't the Google Cloud which is a separate organization from the TPU team, which is a separate organization from the DeepMind team, which is a separate organization from the search team, right? There's a lot of bureaucracy.
Wait, Google Cloud is a separate team than the TPU team?
Technically, TPU sits under infrastructure, which sits under Google Cloud, but like Google Cloud, like for like renting stuff, and TPU architecture are very different goals, right? In hardware, and software, like all of this, right? Like the JAX XLA teams do not serve Google's customers externally, whereas NVIDIA's various CUDA teams for like things like Nickel serve external customers, right? The internal teams like JAX and XLA and stuff, they more so serve DeepMind and Search, right? And so their customer is different. They're not building a product for them.
Do you understand why AWS keeps winning versus Azure for cloud versus Google Cloud?
Yeah,
Google Cloud is tiny, isn't it, relative to AWS?
Google Cloud is third. Yeah. Microsoft is the second biggest, but Amazon is the biggest, right? And Microsoft deceptively sort of includes like Microsoft Office 365 and things like that, like some of these enterprise-wide licenses. So in reality, the gulf is even larger. Microsoft is still second, though, right? Amazon is way bigger. Why? Because using AWS is better and easier. And in many cases, it's
first.
cheaper. And it's first.
It was first.
Yeah, but there's a lot of things that are first.
Well, it's easier. It's harder to switch than it is
Yeah,
to.
okay.
But AWS
Because
is
it's large
their
company.
core.
There's big fees for switching too.
AWS generates over 80% of Amazon's profit. I think over 90%, right?
Insane.
The distribution centers are just like, one day we'll decide to make money from it. But they haven't yet, right? Like they make tiny little profits.
Yeah, one day Amazon Prime will triple in price.
You would think they would improve AWS interface because it's like horrible. It's like clunky.
I have no
But
idea.
everybody is.
I don't. Yeah, one would think.
I think actually Google's interface is sometimes nice, but it's also like they
That's
don't
what
care
I was
about anyone besides their top customers.
Yeah, exactly.
And like their
I mean-
customer service sucks, and like they have a lot less like.
I mean, all these companies they optimize for the big customers. Yeah, it's supposed to be for
Well,
business.
and Amazon has always optimized for the small customer too, though, right? Like obviously they optimize a lot for the big customer, but like when they started, they just would go to like random Bay Area things and give out credits, right? And then they like, or just put in your credit card and use us, right? Like back in the early days. So they've always, the business has grown with them, right? And burgeoned. So like, why does Amazon, like, why is Snowflake all over Amazon? Because Snowflake in the beginning, when Amazon didn't care about them, was still using Amazon, right? And then of course one day Snowflake and Amazon has a super huge partnership. But like, this is the case, like Amazon's user experience and quality is better. Also, a lot of the silicon they've engineered makes them have a lower cost structure in traditional cloud storage, CPU, networking, that kind of stuff, than in databases, right? Like, I think like 4 of Amazon's top 5 revenue products, margin products, sorry, like gross profit products, are all database-related products, like Redshift and like all these things, right? Like, so Amazon has a very like good silicon to user experience, like entire pipeline with AWS. I think Google, their silicon teams, yeah, they have awesome silicon internally, TPU, the YouTube chip, some of these other chips that they've made, and the problem is they're not serving external customers; they're serving internal customers, right?
NVIDIA's entire culture is designed from the bottom up to do this. There's this recent book, The NVIDIA Way by Tay Kim, that details this and how they look for future opportunities and ready their CUDA software libraries to make it so that new applications of high-performance computing can very rapidly be evolved on CUDA and NVIDIA chips. And that is entirely different than Google as a services business.
Yeah, I mean, NVIDIA, it should be said, is a truly special company. Like, I mean, there's a whole, the culture of everything, they're really optimized for that kind of thing. Speaking of which, is there somebody that can even challenge NVIDIA, hardware-wise? Intel, AMD?
I really don't think so. We went through a very long process of working with AMD on training on their GPUs and inference and stuff, and they're decent. Their hardware is better in many ways than NVIDIA's. The problem is their software is really bad, and I think they're getting better, right? They're getting better faster, but the gulf is so large, and they don't spend enough resources on it, or haven't historically, right? Maybe they're changing their tune now, but for multiple months we were submitting the most bugs, right? Like us, semi-analysis, right? Like, what the fuck? Like, why are we submitting the most bugs, right? Because they only cared about their biggest customers, and so they'd ship them a private image, blah blah blah, and it's like, okay, but I am just using PyTorch and I want to use the publicly available libraries, and you don't care about that, right? So they're getting better, but I think AMD is not possible. Intel's obviously in dire straits right now, and needs to be saved somehow. Very important for national security, for American technology dominance.
Can you explain the obviously? So why are they in dire straits?
Going back to earlier, only 3 companies in R&D, right?
Yeah.
Taiwan, Hsinchu, Samsung, Pyongyang, and then Intel, Hillsboro. Samsung's doing horribly, Intel's doing horribly. We could be in a world where there's only one company that can do R&D, and that one company already manufactures most of the chips. They've been gaining market share anyways, but that's a critical thing, right? So what happens to Taiwan means the rest of the world's semiconductor industry, and therefore tech, relies on Taiwan, right? And that's obviously precarious. As far as Intel, they've been slowly, steadily declining. They were on top of servers and PCs, but now Apple's done the M1, and NVIDIA's releasing a PC chip, and Qualcomm's releasing a PC chip. And in servers, hyperscalers are all making their own ARM-based server chips, and Intel has no AI silicon wins, right? They have very small wins. And they never got into mobile because they said no to the iPhone, and all these things have compounded, and they've lost their process technology leadership, right? They were ahead for 20 years, and now they're behind by at least a couple years, right? And they're trying to catch back up, and we'll see if their 18A, 14A strategy works out, where they try and leapfrog TSMC. And Intel's just losing tons of money anyways, right? And they just fired their CEO, even though the CEO was the only person who understood the company well, right? We'll see. He was not the best, but he was pretty good, relatively. Technical guy.
Where does Intel make most of its money? The CPUs still, right?
PCs and data center CPUs, yeah. But data center CPUs are all going cloud, and Amazon, Microsoft, Google are making ARM-based CPUs. And then PC side, AMD's gained market share. NVIDIA's launching a chip. That's not going to be a success, right? MediaTek, Qualcomm have launched chips. Apple's doing well, right? They could get squeezed a little bit in PC, although PC generally, I imagine, will just stick Intel mostly for Windows side.
Let's talk about the broad AI race. Who do you think wins? We talked about Google,
The
Meta.
the default
XA.
leader has been Google because of their infrastructure advantage.
Well, in the news, OpenAI is the leader.
They're the leading in the
They have the
narrative.
best model.
They have the best model that people can use, and they're
And they have the
experts.
most AI revenue.